Hey there, this is Laura from Team 41, also known as the Samurai Corona Caps, and today I'll be walking us through the Ping Wrapper Challenge from the second CTF in-class competition from CSE 365. We'll cover the concepts tested, the tools needed, the approaches we used, and after we find the flag, we'll talk a bit about what you should do to prevent the vulnerability that we'll see in this challenge. So before we jump right into breaking the challenge, let's talk about some of the overarching concepts that are dealt with in this challenge. So Ping Wrapper is a challenge that tests our knowledge of Unix syntax, commands, and delimiters, as well as how to use these to perform command injection attacks that override what a program expects as its input in order to infiltrate a remote server and retrieve a flag. As for the tools we used and the approaches for this challenge, we used several things. The first being netcat, which was just really used to communicate with the remote server, because if we go back and look at the clue for the challenge, we're given an IP address and a port number, so we know that we need to communicate with a remote server probably to get the flag. And we also used a base64 decoding website. Now, it's not obvious now, but when we dive into the source code or when we just run the program, we'll see this garbled text appear in sort of like the intro text that we see, and it resembles something looking like either ciphertext or a hash of some sort. And if we look at the format of that text and compare it to examples of other ciphertext or encoded text, we see that, we eventually see that it resembles base64 encoded text. And so this is the website we eventually used, but of course, when we first started out, we did have to compare it to different types of ciphertext. We also used the Unix manual, also known as the man pages, to learn about different commands because, as you will later see, there were a lot of different commands that we couldn't use that were being checked for. And when we couldn't really figure out where to go, of course, we turned to our good friend Google. We can't not mention Google, even though it should probably just be assumed at this point. So let's go ahead and jump to the terminal and take a look at how to solve this challenge. Okay, so we're at the CTF website here. You're given a binary file as well as a C file, and when we download them and open them up in our terminal, let's see, we can take a look here, and here's the garbled text that we see, which, you know, it could be there for decoration, but chances are good that it's not. So if we take this text and we copy it over to a website that decodes it for us, we actually get a little clue. So the first line goes to I forget to check for a $sign and parentheses. If we decode the second line, it says that's okay, we filtered commands, which we did see them do. But it is a clue that maybe we should take a closer look. If they forgot to check for $signs and parentheses, what else did they forget to check for? So if we look at this line here, their danger, we can see the different characters that they are checking for. So it looks like the author of this program is trying to create like a blacklist of sorts, and we see these different commands that are typically used to access files as well. We see this one's banned, which gives us access to the shell. We see cat's banned. So we have to think about an alternate way to maybe pipe in a command. So it looks like that's what they're trying to check for. So that's maybe something we should see if we can do. And we notice that they forgot the pipe character here. So we could try that out. So if we exit out of here and we try to run the program, we could start locally and see what happens here first before we connect remotely. And if we just sort of put in some random command and then just maybe try ls, because we didn't see that being filtered out for, we'll see that it actually did read that in as a command. And so it's listing all the files that I have here. So if we pipe a command in with some fake thing there, maybe we can see the contents on the remote server too. So let's try that. So if we go back to our clue here and we get the IP address and port number and we use netcat, to communicate. It'll run the program. Let's try the same commands here. And we do get to see everything listed in the current directory. So the clue mentioned a file called flag.txt, and it could be a flag in there, we don't know, but it looks very promising. And if we look here, we do see that file here. So we want to get in there. And the problem now is that this program is filtering out for a lot of different commands. So we had to figure out what else we could use. And that eventually took us down the road of checking out a command called OD. And if we look here in the manual, it explains that it dumps files in octal formats, and we can actually adjust the format of the output. And after trying different things, we can see there's a flag here, C, that will actually print out some of the printable characters too, in addition to the octal output. So we decided to try this. So what we'll do is, connect again to that program. We'll do our phony thing there, foo. And this time, instead of ls, to see what's there, because we know it's there, we're just going to try OD. And we want to see the printable characters. And we're going to put that file name and see what we get back. So when we do that, we do see the octal contents, but then we also see these characters here. And I don't know about you, but if you've been in the CTF competition before, we recognize the format of the flag that's been used. So 365 CTF, and we see the curly brackets there. I am out here. So what we'll do is we'll just copy this output, and we'll go ahead and stick it in a notepad. And I already did that here. And if you take out all these extraneous spaces, we see a flag. And if we enter this into the website, it works. So that's how we found it. So how would we fix this vulnerability? Because it seems like it's a pretty big deal if you can just connect and inject a command. What we would do is, instead of using a blacklist to specify the characters that you don't want or specify the commands that you don't want, we saw that it was really easy to forget and leave things out. So what the program's author could do instead is create a whitelist, and this whitelist will just specify the characters that are allowed. So you could do characters A through Z, numbers 0 through 9, maybe periods will be allowed, so you can type in an IP address, and that's it. That way no one can pipe in and do a command injection attack. So there you have it. Hope you enjoyed watching. Thanks so much and have a safe summer. Bye.